Hello, electromagnetic experts. You should be working on this page, and in the last video we looked at, with a given wavelength, how to solve for frequency in hertz. So now we'll be looking at how to fill out the far right column for energy of the wave in joules. So let's take a look on how we can do this. So I'm looking at a sample frequency of radio waves. Again, the frequency of radio waves would determine the radio station that you might be listening to. This new variable h is called Planck's constant. It has kind of a funny spelling, so oopsie. Kind of a funny spelling, so let me get my pencil. H equals Planck. And it's a very small value that relates it's a constant. You don't necessarily need to memorize this, but you might accidentally end up doing that. And the units are joules times seconds. And this is something that tells us the relationship between the frequency of an electromagnetic wave and the energy it contains. So we're going to talk about the kind of comparisons of energies in each wave and each color of visible light. And this Planck's constant value helps us look at that relationship. So I think the trickiest part of this equation is just, dealing with the scientific notation in the calculator. But the relationship can be signified with another 3-variable equation, which states that the energy of a wave equals h, or Planck's constant, times the frequency of that wave in hertz. So for this example, we're solving for energy, and our equation, if we're solving for energy, is going to be h times frequency. Okay, and hertz is the SI unit, and joules times seconds is an SI unit, so we don't have to stop, drop, convert. And so if I plug in here, I would have energy equals 6.63 times 10 to the negative 34th joules seconds times 3 times 10 to the 5th hertz. Okay, in my calculator, I'm going to plug in, I'll type what you would plug in, 6.63, and then on the screen you can see the red arrow points to the button that's on my sideways view of my calculator on my phone. So I would click EE and then the exponent, so negative 34, because 34 zeros aren't going to fit on your calculator screen. And then we would multiply this by 3e, and this is a positive exponent, meaning it's a large number, 3e5. So let me type this in and double check what we get. If you have a scientific calculator at home, you might have a button that just says capital E. Do not use the lowercase e button, that stands for something else. You might have a button that says times 10 to the, but this is kind of the shortcut way. So 6.63 EE negative 34 times 3 EE 5 equals, and the energy I get, it's a very small value. I got 1.99. Scientific notation always round to the 100th, times 10 to the. So on my calculator screen, it shows me this is what it says, 989 e negative 28. So I would write this as 1.99 times 10 to the negative 28th, and then the SI unit of energy is joules. So this would be my final answer that I'm going to plug into the far right column of the electromagnetic experts chart. So you'll get a lot of practice typing in exponents and scientific notation into your calculator. Please email me if you have any questions, and hope this is helpful. Doodles.